If you were a jackrabbit hopping through the desert, you'd be glad to stumble, well, maybe not stumble, across a cactus. The succulent flesh of these plants is a water source for many desert animals. Native to the Americas and known for their spines and succulent stems, cacti of all shapes and sizes have evolved to not just survive, but thrive in some of the harshest desert climates on Earth. So how do they do it? A cactus's spines are one key to its survival, but not for the reason you might think. Take a look at the prickly pear. Its spines are highly modified leaves. A normal leaf's large surface area would be ill-suited to the desert, transpiring massive amounts of water under the baking sun. The dramatically reduced surface area of the spines limits water loss. They also shade the cactus and reflect the sun's rays, reducing the plant's core temperature during the heat of the day. Then at night, when air temperatures plummet, the spines act as an insulating layer, keeping the cactus from cooling down too much. These functions are just as important, if not more, than defending against predators. From Cuba to Mexico and as far south as Brazil and Peru, melon cacti grow on limestone soils in seasonally dry tropical forests where they're constantly exposed to the beating sun. They rely on another adaptation common to cacti, a thick skin, which is coated in a waxy substance called a cuticle that limits water loss. Meanwhile, the stomata, tiny holes that allow the exchange of gases that enable photosynthesis, remain firmly closed until night, when they open. The lower temperatures at night mean the cactus loses less water from the stem when the stomata open. The bulk of the plant acts as a large barrel of water, storing it for times of need. But to survive the desert, a cactus can't just limit water loss. It has to be prepared to take full advantage of the rare situations where water is readily available. In North America's Sonoran Desert, the towering saguaro cactus can grow up to 20 meters tall and live for up to 200 years. Woody tissue, like the kind found in tree trunks, gives the saguaro its height, but the saguaro survives with way less water than most trees. Most of its roots are only a few inches deep. Just below the soil's surface, they spread out laterally for meters and hold the plant in place. Even its single deepest root, the taproot, extends less than 1 meter into the ground. After a rain, the lateral roots respond in real time, rapidly growing and spreading. They produce ephemeral rain roots that quickly take up the available water. The water is then pulled up into the plant body and stored in cells that contain mucilage, a gluey substance that clings to water molecules and stops them from evaporating if the plant's tissue is ever damaged and exposed. As the soil dries after the rain, the small rain roots also start to dry and wither away, and the cactus awaits the next time it can take advantage of a shower. Taken together, these features make cacti well equipped to survive their environments. From the driest desert to a tropical rainforest, the mistletoe cactus can live on the branches of trees in the rainforest. Though there's lots of water around, not much of it reaches the cactus here, and there's nowhere for its roots to go. So even here, the cactus survives using adaptations that long ago helped its ancestors survive the desert. Other plant adaptations more closely resemble booby traps. From bedbug harpoons to fly swatters, check out some of the amazing ways plants defend themselves with this video.